try another problem that your instructor talked about in lecture. And again, I'll give you about a minute to work on this on your own, but then we'll just go through it together. Yes. Do you have that with you?
Yeah.
So are you looking at the right slide now? This is the slide on page 532. It's the slide that's labeled page 532. It's towards the very end. C7H14-0. That's right. So let's take a minute to try to work that out separately, and then we'll work through this together.
time determining the chemical shift just by know how to break the area along the x-axis. I could take guesses, I guess.
Which group is your group A? Point to group A. Now, this solid white line should represent the number 2, and this solid white line should represent the number 3. And notice that there's faint lines in between. How many faint lines are there between the solid lines? Oh, you can't see them?
Yeah,
oh, all right, that actually might be a difficulty for you on the test.
Yeah.
You need to make a plan for that. So, do you usually wear glasses? Or? Okay. Okay, well you might need to talk to your instructor about that if you can't read the graph. Although even then you can just estimate how far along is this.
Less than a half.
Yeah, that's right. And that's likely to be close to that. Yeah, that seems like a very good approximation to me there. So yeah, that group A, I think I would approximate it at 2.3, although maybe you were more right, 2.4, I don't know. So, yeah, it's actually hard for me to see those faint lines too. All right, so let's approximate group A at around 2.3.
Not really.
And then group B.
And I'd say probably about 2.15.
That's fine, I'll call that 2.1.
And C about 1.
Yeah.
ABC just randomly defined, right?
You could call it whichever you want, A, B, and C. You might as well do it from left to right, though. That's right. So those are just our reference letters.
And S stands for singlet?
That's right.
Okay.
These are the standard abbreviations for splitting. Singlet, doublet, triplet, quartet. Then you have to spell things out a little bit more. Quintet, sextet. All of a sudden I can't remember if this is called a heptet or a septet, but this would be for 7. Heptet, you think so?
Yeah.
All right, maybe. I know that when you're, well, okay. Then octet, maybe this would be a nonet. That's about as high as you're likely to have to go.
So I think I've gotten about all the information that I can.
Good. Now, notice in this case, it was easier. In this case, they didn't give us the areas. They directly told us the number of hydrogens.
Now, can we assume that these are exactly the hydrogens we, or is this going to be?
If they actually
4,
write the
6?
H, then you can assume that's the right number of hydrogens. What's happened here is the computer has just done the work on its own. It's already taken the ratio of the areas, and the computer was told the molecular formula. Since the computer's told the molecular formula, it can use the ratios to find the exact right number of hydrogens.
Okay.
So 2, 3, and 9. When they give you the integration with the letter H, I think that generally means that's the exact right number of hydrogens. So here the integration is easier than before. Of course, it's easy to check that. We just have to make sure these add up to 14. But they do add up to 14.
Right.
Got off to a good start here because you remembered to find the index of hydrogen deficiency, also called the degrees of unsaturation. Again, we got an answer of 1 because the number of carbons was 7. And then we had to subtract the number of hydrogens. There was no nitrogens or halogens. Remember again that the number of oxygens does not appear in this formula. So the number of oxygens doesn't affect our degrees of unsaturation. Again, we know then that there's either 1 pi bond and 0 rings, or 0 pi bonds and 1 ring.
All right.
We'll have to decide which of those it is. What would N be for group A then?
0.
This is interesting information. It seems that none of the groups of hydrogens are adjacent to other hydrogens. That should strike us as kind of weird. It seems like how can we find enough room in the molecule to make sure everyone's not adjacent to each other? Hopefully that'll be a useful clue to us. It's unusual to get all singlets. Let's see if there's any other clues that we can get here. Now, does it seem like any of these groups is on a carbon that's connected to the oxygen? Does it seem like any of the hydrogens look like this?
No.
No? How about like this?
Possibly.
Which group would that be?
A.
Group A looks like it's in this region over here. It's far enough to the left to be connected to a carbon with an oxygen, but probably not to have the oxygen on it itself. And maybe group B as well over here would be in that same place because that's also bigger than our 1.25 region over here. So both of these might be connected to the carbon with the oxygen.
Now, so just really quickly to kind of skip back to determining the hydrogen deficiency. Once we looked at our chemical shifts, do we need to take the fact that it looks like we're going to have an alkane because everything's to the right of 5?
Right.
Or not?
Should we take that into account? Absolutely.
Take that effect immediately or
we should certainly take that into account. So one thing we should say to ourselves is it looks like there's no carbon, it doesn't look like there's carbon-carbon double bonds. Although it's possible that there could be an alkene, just as long as it's an alkene with no hydrogens.
Sure.
There could be an alkene as long as there's no hydrogens directly on the alkene.
Okay. Thank you.
We were working on this fragment here, and it looks like these hydrogens can't be on this carbon, but they can be on this carbon.
Correct.
And how many hydrogens does it look like there are on this carbon?
2.
2, because this has an integration of 2. That's only a guess, because it's possible that it could just be one hydrogen on the left and one hydrogen on the right. Another possibility is that it could look like this. We could have one group A on the right and one group A on the left. Although then we'd have to have a lot of extra bonds on these carbons. It might be hard to fill these up with enough bonds if there can only be one hydrogen in each place.